Okay. Good morning. So this is our lecture number 3. We have been discussing about the general commands which is coming in general. So you can look at the computer screen. If I make doc general, we will see help window where you will get all the general purpose commands. I will delete this, so you will get here. So we have discussed about each of them: help browser, doc for documentation, help windows, look for, that is searching for a particular command, then syntax, support, demo, version, etc. Then managing the workspace, who to find out what are the variables in the workspace, who has, that is variables with size and all other knowledge about the variables, clear, pack, load, quit, what type, edit, open, which pseudocode, in mem, makes, etc. We also discussed about what are important, what are not important, and you stored it in some file. So those important commands, you please look at my last lecture, you will find which are important, which are not important. For example, what, who, has, clear, load, save, quit, these are important. Workspace, pack, they will not be so important because your memory is very high nowadays. So path, add path, they will not be important because you will be using the GUI to change the path. And echo, more is important. Diary is important when you try to learn something. Then format is sometimes important, but most of the time it is not. CD will be important. Move file, copy file will not be important. Delete, PWD, DIR, they will be important. Then mkdir will be also important. So most of the other commands will not be important. And then when you come to debugging, right now let us not discuss about debugging, because only when you write some large programs and you have large data structures to handle, when you commit mistakes, numerical mistakes, not syntax mistakes, so you will use this. So they can be used inside your .m files to stop at a particular place, to watch a particular variable, or to know details about the command flow when you convert your algorithm into a program. So these things we will not discuss right now. So we will now move to the next in the line of the MATLAB structure. As you can look at my slides here, that is, first one was MATLAB general, then we shall discuss about MATLAB operators and special characters. So in the second line we have got the operators and special characters. You have already created that file. If you will go to that file, you will find this operator and special character. I had saved this file somewhere in the desktop. Let us find out where did I save. So we have saved somewhere, learn MATLAB. So here in the date I have saved this, if you remember correctly. So this is my favorite Word file where I saved this. So this next one in the command was MATLAB operators and special characters. I will increase the view, make it so operators and special characters. So we have already discussed about general purpose commands. So let us go to operators and special characters. Go to simply type doc general. Doc OPS will give you the operators and special characters. You can see here. So what is plus, u plus? Plus and u plus, basically u plus is a sign, plus is addition. Similarly, minus is a sign and u minus is just a sign. U minus is the subtraction. Suppose I look at the command prompt, I write CLC to clear it. Suppose I write one variable x1, which is a matrix of 3 elements, 3, 4, 3, 5, 2, 3, 4, then 5, 6, 7, then 9, 8, 7. So x1 is a matrix. So x2 I will write another matrix, 2, 4, 5, then 6, 7, 9, 8, then 9, 1 and 6. So I can do x1 plus x2 directly. The dimension has to match x1 minus x2. I can also do x1 into x2. So these are all matrix addition, subtraction and multiplication by using plus, minus and star. Now I can write also minus x1 then plus x1. So plus minus here are unary plus, just you have to say the sign in the x1 matrix. Then m times is matrix multiply. So matrix multiply, what is the symbol? Star. I have just done it. There is one something called times, only times. What is times? Times is RA multiply. What is RA multiply? For example, x1 into x2 is the matrix multiplication. So what is x1? This is my x1 and this is my x2. But if I do x1 star x2 dot star x2, you will find it will multiply element by element. So the element 2 will be multiplied this first element, the second 1 2 element will be multiplied with the 1 2 element of x2, 1 3 element of x1 will be multiplied with the x1 1 3 element of x2, like that. So each of the elements will be multiplied by each of them. So that's why it is x1 dot x2. So here for this particular operator to satisfy, the number of elements and rows and columns in x1 should be equal to number of rows and columns in x2. So you see what is happening. You see the element by element multiplication has already taken place. You can see you choose any one of them. So last one is, this is 7, this is 8. So 7 into 8, 56 you got. So this is your multiplication by individual elements. So x1 star x2 is the matrix multiplication. So matrix multiplication will be valid when the dimension number of rows number of columns in x1 should be equal to number of rows in x2. That means m cross n matrix x1 should be multiplied with an n cross p matrix x2. So that means the number of columns in x1 should be equal to the number of rows in x2 for matrix multiplication. But for element by element multiplication, the number of elements in x1 should be equal to the number of elements in x2 and the dimensions should be same. You can multiply two vectors. For example, I shall define a vector, random vector rand 5, 1. This is a random vector. Similarly, I will define another rand vector. So 5, 1. So you know what is the difference between rand n and rand? Rand n generates random numbers normally distributed with 0 mean and the standard deviation is 1. Rand is a uniformly distributed random number between 0 and 1. So rand n is random numbers normally distributed between, the limit is minus infinity to plus infinity, but the mean is 0, the standard deviation is 1, therefore the variance is 1, and this is uniformly distributed random number between 0 and 1. So this will give me a 5 cross 1 vector, this will give another 5 cross 1 vector. So I can only multiply element by element, that is x3 can be multiplied with x4 element by element to get a vector. But you cannot multiply x3 into x4, it will give you error because the dimensions are not matching. However, you can multiply x3 transpose with x4 because that becomes 1 cross 5 and that becomes 5 cross 1, that will give you a scalar, right. Similarly, you can multiply x4 transpose with x4, which will give you the magnitude square of x4. Is that clear? So this is actually multiplication and element by element multiplication. Similarly, matrix power. So what is matrix power? That is, power means multiplying the same matrix with itself. Dot, this dot, array power means dot to the power dot cap, that means powering the individual elements of that particular array, right. So you can see that suppose x1, if you do square, x1 is multiplied with itself, but if you make the x1 dot square, the elements of x1 are squared. This is your x1, you can see. So 2 square is 4, 3 square is 9, but x1 into x1 is same as x1 square, and x1 dot into x1 is same as x1 dot square. See? Similarly, you can write x1 to the power, let us say 10. So this will give you x1 multiplied by itself 10 times. But if you do x1 to the power dot to the power 10, the individual elements will be power to the power 10, right. So now there are two more important things called backslash or left matrix divide and right matrix divide. These are very important. What is backslash right matrix divide and left matrix divide? It is like this. Suppose, so let us look at this. Matrix divide is same as solving equations. So you can see, look at the slides. Suppose I have an equation like this, Ax is equal to b. So this represents a set of linear equations. Let us say let A is a 3 by 3 matrix, X is a 3 cross 1 array, B is a 3 cross 1 vector. So this is known, and this is not known, let us say. So let us say A is some 5, 9, 18, 3, 1, minus 5, 7, 11, 37, something like this, let us say. Then B is equal to, let us say, 5, 19, 31, let us say. So what will be, so I hope that A is having full rank. So what is, how do you solve such equation? So this represents a 3 cross 3 equation, is it not? So since this represents a 3 cross 3 equation, how do you solve? In your high school days, you have used actually Gaussian elimination, is it not? It is something like this. You would have written like this: A11 x1 plus A12 x2 plus A13 x3 is equal to B1. Similarly, A21 x1 plus A22 x2 plus A23 x3 is equal to B2. Then you would have written A31 x1 plus A32 x2 plus A33 x3 is equal to B3. So how did you start? You first eliminated x1 and x2, let us say. You eliminated x1 and x2 from this equation. How did you eliminate? So you divided by, so divide this equation throughout by A31, A31, the first element. So after that you get some modified equation. Then here you divide A31 divided by A21. You multiply A31 and divide A21. So then subtract. So after subtraction and all modifications, so you will modify all the elements. So finally what you are going to get, don't touch this. So what will happen? A11, don't touch equation 1, others you modify B1, then you will get something like A22 dash, because it has been modified, plus A23 dash x3 is equal to B2, then A33 dash x3 is equal to B3. So now x3 can be found out from here by just dividing here, then by back substitution you do this. So what is this? This is a upper triangular system you got. We will discuss these systems in detail next, but however this is called Gaussian elimination. How did you eliminated the variables in the equations, then solve for the last equation, then back substitute. So this divide, basically the left divide, will do equation solution by Gaussian elimination. So let me now put my matrix here. Look at my screen. So A is equal to, let us say, I will put 5, 9, 18, then I will put 3, 1 and minus 5, then my next one is 7, 11 and 37. So this is a matrix A. Then my B is a column matrix, so 5, then semicolon, because I want to go to the next row, 19, 31. So this becomes a column vector. So what will be X? X will be A backslash B. So that gives me the value of X. You can see A into X minus B will be all 0, 10 to the power minus 13. This says that this is all of them is multiplied by 10 minus 10 by 10 minus 13. So what did I do? I did a backward slash. This is backward slash, means left divide, because you are writing an equation here. Look at my slide. Ax is equal to B. So you are actually dividing. You are multiplying A inverse then B. But in this particular case, you are not going for A inverse. So inverse is not calculated, but the solution is done by Gaussian elimination. Always remember, Gaussian elimination is faster than finding out the inversion. So whenever you are trying to solve a set of linear equations, never ever go for solution of linear equations. Don't go for inversion. Always use Gaussian elimination. I can tell you why. Suppose you have a matrix, let us say W. You want to find out the inversion. That means you want to find out a matrix Z, so that all of them W multiplied by Z is identity. So this is not known, this is known. So this is also no identity matrices. So this is, let us say this is a 3 by 3 matrix. So you have got W11, W12, W13, then W21, W22, W23, then W31, W32, W33. Then Z is not known. So this will be Z11, Z12, Z13. So Z21, Z22, Z23, then Z31, Z32, Z33. So these values are not known. These all of them are to be found out. And here you got 1, 0, 0, 0, 1, 0, and 0, 0, 1. So how many equations are there? Can you tell me? Here the number of equations, if you see, if you make all of them, put these all Z's in an array like this or vector like this, you will find there are 9 variables. So there are 9 equations to be solved to find out the inversion. But whereas to find out this, to solve this, you have to only solve in only three equations. Therefore it is having much more complex, its complexity is much less than the complexity of finding the inversion. So this method is not used. So this forward backward slash is basically left division, and that is called Gaussian elimination. But there is sometimes a problem. The problem is like this. The problem is, suppose you have a matrix A, x is equal to b, where suppose the number of unknowns are only 2 and the number of equations are, let us say, 3. So this is a 3 cross 3 matrix, 3 cross 2 matrix, and this is a 2 cross 1 matrix, and this is a 3 cross 1 matrix. That means my equations are like this: a11 x1 plus a12 x2 is equal to b1, one equation. Then a21 x1 plus a22 x2 is equal to b2, another equation. Then a31 x1 plus a32 x2 is equal to b3. So you can see there are 3 equations but only 2 unknowns. So what is the solution? The solution is there only when one of these equations is dependent upon the other. That means by multiplying something here and making some algebraic manipulations, I should be able to get this, is it not? But actually suppose there are 3 independent equations. Geometrically, what does it mean? Geometrically, if there are 2 variables, you can say that if there is a variable x1 and x2, if there are 2 equations, the 2 equations basically represents 2 straight lines. These are 2 straight lines. So wherever they cross, that is the point of solution. If they don't cross, that means the straight line parallel to each other, they don't cross, there is no solution. But in this case, what is it? There are 3 straight lines. So this is equation number 1, this is equation number 2, this is equation number 3. So there are 3 straight lines, they do not intersect at the same point. If they intersect at the same point, then you can say there is a solution. Because they don't intersect at the same point, there is no solution. But in engineering and science, for engineering and scientists who do numerical methods, you will find they come up across such systems very often. So therefore this equation has an approximate solution. That means find a solution which will best satisfy all these equations. So how to find that solution? That means you have to find a point where it will have the least distance from each of the straight lines. That means the perpendicular distance from equation 1 will be plus the perpendicular distance from equation 2 or the straight line 2 plus the perpendicular distance from equation 3 will give you the solution. So this is my point of solution, and this is known as least square solution. So how do you do least square solution? So you have 3 equations. So what you do is you assume that by solving each equation will result in error, because you will never get a point where all the equations will be satisfied, but you will get a point where maximally all of them will be satisfied. So how to do it? So therefore you have to basically find out the hypocenter of the triangle formed by the intersection of the straight line. This is, if you draw the perpendiculars, this becomes the hypocenter or whatever you call it in geometry. So how do you find out? So what I shall do is I will find out one error. What is error? Ax minus b. So this error has to be minimized. This error can be positive or negative. So what shall I do is I shall find out the square of the error, E transpose E. So in this case, how many errors are there? There are 3 errors for 3 equations, is it not? So E transpose E turns out to be E1 square plus E2 square plus E3 square. So this will be, if I write Ax minus B transpose into Ax minus B. So this is my error. So if this is the error, so if I expand this, that turns out to be X transpose A transpose A into X minus X transpose A transpose B minus B transpose AX minus 1 plus B transpose B. So this is my error. So this error has to be minimized. So how do I minimize this? I shall minimize this error with respect to X. That means I will find out the gradient of this E with respect to X and equate it to 0, and that is my minimum point. So how do I do? So if I find out the gradient, this will go into vector differentiation. If you can also do it by scalar differentiation. That means error can be expressed as sigma, you can see a11 x1 plus a12 x2 minus b1 whole square, or you don't forget about sigma, you can write just like that, plus a21 x1 plus a22 x2 minus b2 square plus a31 x1 plus a32 x2 minus b3 whole square. So you differentiate. So what is gradient of x? So gradient of x is, it implies del E by del x1, del E by del x2 and del E by del x3. I will write in a different paper. So that means del E by del x1, del E by del x2, del E by del x3, which is same as gradient of E with respect to x should be equal to 0, all zeros. So if you differentiate it, I am not doing all the exercise, it is left to you. So if you differentiate this, each of the equations, you differentiate each of the equation and equate to 0, how many equations you will get? You will get exactly 3 equations. You will get 3 equations. Sorry, I don't have 3, right? So only 2 variables will be there. So they will get 2 equations and there will be 2 unknowns, because you are taking the gradient with respect to x. There are only 2 variables, x1 and x2. So with respect to x1 you are differentiating, and with respect to x2 you are differentiating and equating to 0. So that means, so this will be equal to 0 and this will be also equal to 0. So these 2 equations will generate 2 independent equations. Most likely, remember, most likely, it may not be also case always, but most likely these 2 will generate 2 independent equations, and these 2 independent equations can be solved to generate the least square solution. So now I shall just write in the vector form, because I am more equipped. I shall tell you that if E is equal to x transpose A transpose AX minus x transpose A transpose B minus B transpose A into X plus B transpose B, if you take the gradient with respect to E, you will find this turns out to be A transpose A into X into 2, this turns out to be minus A transpose B, this will also turn out to be minus A transpose B. This is the rule. If you differentiate this expression with respect to x, this will turn out to be 2 into A transpose A into x. This is the rule. This is the rule of vector differentiation. Similarly, if you differentiate this with respect to vector x, you will find this will be A transpose B. So what is differentiating with respect to x? That means you will differentiate with each of them, then write in the vector form. That's all. So that is differentiating, and this rule is valid. So this you want to be equal to 0. That means this implies A transpose A should be equal to into x should be equal to A transpose B, because this will be 2. So 2 will be over, and x will be equal to A transpose A inverse into A transpose B. What is this? This is your generalized inverse. Inverse, or this is also known as pseudo inverse. There are various issues. For example, A transpose A is not invertible. That means it is singular. The rank of A transpose A is less than what is supposed to be. What should be the rank of A transpose A? Should be 2, because A is a 3 by 2 matrix. So this should be a 2 by 2 matrix, A transpose A. If the rank is not 2, it is less than 1, then this will not exist. So there are other issues which we will discuss eventually, but for the time being, let us be satisfied with this pseudo inverse. Now suppose I want to take an equation just like the one. So now instead of writing the values, I will generate random numbers to make my A matrix. So I shall do clear. So then CLC, then I shall take one matrix A, which is equal to rand of Let us say I will generate a 3 by 2 matrix, any equation. Then I have B, which is also a 3 by 1 matrix, 3 comma 1. Now what is my equation? Ax is equal to B. So what will be x? X is equal to, what is x? X is equal to, I said that it is inverse of A transpose into A whole into A transpose into B. This is your x. This can also find out by same. This x can also be found by A backslash B. See? So this backslash is same as pseudo inverse. It is also same as inverse. So they are solved by least square problems. Okay. So backslash is clear. Forward slash is just opposite. Suppose you write the equation, you can see it is same. Same thing, only thing the equation has to be written. This is called left divide, one is called right divide. Suppose you write an equation like this. Look at my slides. Suppose you write an equation like this. XA is equal to B. Then x will be equal to B into A inverse. So this is right divide, right? So x can be a vector, x can be matrix or whatever. Suppose x is a matrix, XA into B. That means this is a matrix of, let us say, 3 by 3. This is a matrix of 3 by 3. This is a matrix of 3 by 3. So I want to find out x. Therefore x will be B into A inverse, right? This is called right divide. Similarly, you can have also least square solution. For example, suppose the number of equations is equal to more than the number of unknowns. So then also the same principle applies, and you will also have a least square solution. This is same as this is same as, what is same? A transpose X transpose is equal to B transpose. So this is actually X transpose is equal to A transpose inverse into B transpose. So this is same as, again, this is left division. So this is not, there is not much difference, right? So you have learnt what is a least square solution and how you will achieve it by backslash and forward slash. You can see MLD divide. You can, suppose you want to know more about it, you can see what is backslash. It is clearly written here what is backslash. Then similarly MR right divide, it says you about the forward slash. It is very simple. It is same thing as this. That means A slash backslash B is same as B forward B transpose forward transpose. This is same. They are same. Right? So now go back. Okay. So array divide. Now you call array divide. Array divide means this was inversion. Suppose I want to divide element by element. So A dot backslash B means Aij backslash Bij for all ij. That means the elements of A will be divided with the element of B. So in this case, actually your A and B matrix should have same dimension. Right? Clear? CLC, define one a matrix A and let us say 4 comma 4 and 4 means it is a 4 by 4 matrix. Then B is equal to another rand 4. So you can write A dot B means A will be divided with B. B, similarly A dot forward slash B means it will be, one is left divide, one is right divide. That means it will be, one will be divided upon the other, this will be divided upon this. So this is what right divide and matrix left divide. You see, unity by element divide, RD divide. Then there is something called Kronecker product. What is this Kronecker product? I shall highlight on this Kronecker tensor product. If there are two matrices X and Y, I shall highlight on the Kronecker tensor product. You will understand what is Kronecker product now. So what I am going to tell you is about Kronecker product. So what is Kronecker product? Suppose I have a matrix A and another matrix B. This is having, let us say, dimension 3 cross 3. This is also having 3 cross 3. So Kronecker product is represented like this. B is equal to A11B, A12B, A13B, A21B, A22B, A23B, A23B, A31 into B, A32 into B, A33 into B. So a scalar multiplied by B, what does it give you? What is A11 into B? So this will be a matrix, is it not? A11 B11, A11 B12, A11 B13, A11 B21, A11 B22, A11 B23. Similarly, A11 B31, A11 B32, A11 B33. So this is a 3 by 3 matrix. So this is 3 by 3, this is again 3 by 3, this is again 3 by 3, each of them is again 3 by 3. So what is the dimension of this? 9 cross 9, because 3 by 3, 3 by 3, 3 by 3, 9 rows, 3 by 3, 3 by 3, 3 by 3, 9 columns. So this will have 9 by 9. If A is of dimension n cross n, B is of dimension n cross n, then what will be the Kronecker product dimension? It will be n square cross n square. So this is Kronecker product. This is used in various applications. So I shall tell you some properties of Kronecker product, then you shall understand what is the Kronecker product and why it is used. So out of the various properties, I shall only highlight on few, that is the inverse of, for example, A Kronecker product inverse is same as A inverse Kronecker product B inverse. Similarly, you can also have other properties like A Kronecker product B plus C will be same as A Kronecker product B plus A Kronecker product C, right? Similarly, A Kronecker product B Kronecker product C will be A Kronecker product B Kronecker product C. But always remember, A Kronecker product B is not same as B Kronecker product A. This is not true, right? So you can have similarly A plus B into Kronecker product C will be same as A Kronecker product C plus B Kronecker product C. So this law is also not valid for ordinary matrix multiplication. A into B may not be same as AB. Similarly, K into A into Kronecker product B will be A into Kronecker product KB same as K into A Kronecker product B. So these are some of the rules you will find if you go to any general website for Wikipedia or something, you will know about Kronecker product. There is another product. Suppose I have a Kronecker product, then a matrix multiplication C cross Kronecker product. So this is one matrix, this is one matrix, and these are Kronecker products, but this is a simple matrix multiplication. What will be the Kronecker, the resultant? The resultant will be A Kronecker product, AC Kronecker product, BD. This is a very important result. Similarly, there is something called spectrum. What is spectrum? Spectrum is known as the set of eigenvalues are called spectrums. Of a matrix. So the spectrum of A is same as the eigenvalues of A, the set of eigenvalues of A. You will know in higher classes, or if you are working in signal processing, the spectrum of a signal will be same as the eigenvalues of its autocorrelation matrix. So this is a very important result. So therefore we call it spectrum. Suppose there are two matrices A, and A has eigenvalues lambda 1 to lambda n. It is an n by n matrix. Similarly, B is another matrix whose eigenvalues are mu 1 to mu n. So what will be the eigenvalues of A Kronecker product B? So this will be, how many eigenvalues will be there? First of all, there will be n square eigenvalues, because the dimension is n square plus n square. So this will be actually lambda I into mu j for I varying from 1 to n and j varying from 1 to n. So this is called Kronecker product. Or if the dimension of B is different, let us say dimension B is q, then this becomes q square. So it will be varying from q. So therefore there will be an n square cross q square number of eigenvalues, that is lambda 1 mu 1, lambda 1 mu 2 up to lambda 1 mu p. Similarly, lambda 2 mu 1, lambda 2 mu 2 into lambda 2 mu p. Similarly, you will just go on. These are all eigenvalues of the Kronecker product, right? So there are various other issues in a Kronecker product, but let me see what is the application of this Kronecker product. So one applications which I will tell you is for matrix equations. For example, suppose you want to find out, suppose a matrix equation, you will find these equations will be very commonly used. So if this is a equation, suppose A is known, B is known and C is known, but you want to find out what is X. So X is also a matrix. Let us say A is a matrix M cross M, this is a matrix M cross M, this is also M cross P, let us say, and this is P cross P. So this is an M cross P matrix, let us say. So how many unknowns are there? So there are M cross P unknowns in X, which is having dimension M cross P. So how to solve it? The solution is, of course, you can do it by just invert the matrix A and multiply here, then invert the matrix B. So what the one solution is, first multiply A inverse in both the sides. So that means X will become A inverse C into B inverse. So this will be having lot of, it will take lot of time, because as I said, finding out inversion is not a joke, it will take lot of time. So instead what you should do is, you should do, this can be represented simply by, this equation can be represented B transpose Kronecker product A into vect X is equal to vect C. What is vect X? Vect X is same as writing, what is vect X? Vect X is same as writing one column of X, then the next column, then the next column, like that. So that is vectorizing this. Suppose x11, x12, then x1 m, then x21, x22, like that you just go on writing. So that becomes vect X. So this vect X will be how much dimension? This will be MP cross 1, and this will be naturally, if you are there, this will be MP cross MP. The dimension will be MP cross MP. So this will be, earlier I told it is n square q square, now it will be nq cross nq. So this will be MP cross MP. So this will be mq cross 1. So therefore this equation can be now solved suitably by Gaussian elimination, and your complexity will be less. So this is one application. There are various other applications. So now let us do this Kronecker product. You see, this is the Kronecker product you have just seen, K-R-O-N, Kronecker. So now you do A is equal to, let us say, identity matrix. Just I am trying to have fun. So 4 by 4 identity matrix. B is, let us say, a random matrix of 3 by 3. Now let me write Kron A comma B. What is the dimension of this? So dimension of A is 4 by 4 and B is 3 by 3. So it should be 12 by 12. So what is the dimension? You can see the dimension is 12 by 12. Let me write Z is equal to, Z is equal to a Kron. So what is the size of Z? 12 by 12. So how does it look? Can I see Z? Of course I can see. Suppose it is not, you cannot see here, just do one thing. Remember, you can plot, or you can make bar 3 Z. It will be plotted. You can see the matrix clearly. See, this is the matrix. There are 12 columns and 12 rows. You can see. So only there are some elements in the diagonal. There are no elements. All other elements of diagonal is 0. So this is a almost a diagonal matrix, or bidiagonal or tridiagonal matrix. You can see that. So this can be by, you can visualize the matrix by putting bar 3. You can also visualize the matrix by surf Z. That means it will give a surface plot. You can see this is a 3 by 3 matrix. So the orientation, etc., I will tell when I tell you about graphics. That means it is a diagonal matrix, right? All right. So if you want to know about the diagonal, you want to extract the diagonal of X. So you can write Z. You can just write diagonal Z. You will find these are the diagonal matrices. All right. Now I shall go to the next command. So you have learned about Kronecker product. left divide, right divide. So these are some of the very important operators called arithmetic operators: plus, u plus, minus, u minus, RA time matrix multiply, then RA multiply, or the point element by element multiply, matrix power, RA power, right divide, left divide, Kronecker product. Now we shall discuss something about the relational operators. What is a relation operator? So the result of an relational operator gives you a true value, whether it is true or false, right? Something is greater than or equal to. You will find this EQ, NE, LT, GT, LE, GE are used for if and while statements. When we shall discuss about language, you will find these operators will be used to generate a logical value, whether it is 0 or none. 1. Suppose 3, I write EQ 2, sorry, 3 EQ 2, sorry, not like this. EQ means you have to give that symbol, I am sorry. So this EQ means this symbol, double equal to CLC 3 double equal to 2. What should we get? You should get false, that means you should get 0. So that is a logical 0. So if you write 2 EQ 2, it is 1. Suppose you equate x is equal to 9, then you write x equal 9, you will get 1. Yes, it is true. Similarly, x not equal to 9, you will get not equal tilde equal to 9, you will get 0. That means it is false. Similarly, greater than, less than, greater than, less than, equal to. So these are all logical operators. So you can see here, these are actually the name, but these are the symbols for which you have to use. All right. You can also write, let me try EQ x 9. So that is how you write EQ. LT x 9. So, but you should write like this, okay. But you can write LT, then x and 9 in bracket, that is possible. So these are functions, but you can use these symbols instead of these functions, right. So you can write G, for example, G 3 comma 9, you should get 0, is it not? But G 9 comma 3, you will get 1. Suppose I will write G, let me write 9.0000000000001, okay, or EQ, let me write EQ 9.00001 with 9 with 9. Let us see what you will get. You get 1. That means it is almost equal. So you are getting 9.001. Let me see where it will distinguish. It is 0. Now it is 0. How many zeros it is taking? One more 0, it is 0. One more 0, it is 1. That means this is the resolution. That means within this value, if 1 is there, what is this? How much is this value? Let me see. You write here. So this is 10 to the power minus 16. 10 to the power minus 16, and there is one FEPS, which is 2 to the power minus 16. That means if the value lies between plus minus epsilon, it will be equated. So here it is actually this value 9.0001, and 9 is the difference between this and this is less than epsilon. Epsilon is the smallest small number in MATLAB. So if it is less than this epsilon, it will be saying that it is equal. Okay. So this is a very interesting conclusion. So then logical operators. So these are all relational operators. So similarly, you will have logical operators. That means you can element wise logical and you can do. That means this has to, the input to this particular function should be binary numbers. For example, suppose I have a number like this, 1 0 1 1, let us say. Similarly, y is having 1 0 0 1 1. So if I write and x comma y, let us see what you get. I get 0 0 1 1. Similarly, or x comma y, I will get or. Similarly, XOR x comma y, you can get like this. I can also write like x. I can also use symbols. For example, x and y. This is also symbol. You can also write. This is also is possible. Similarly, x or is this symbol. Similarly, XOR, what is the XOR? You can see this, the corresponding symbol here. XOR means you have to write XOR only, but there is no symbol for it. Invert is there. So like x, this is invert. So x is this, so inverse is this. You can also write not x, that is also inversion, not x, that is also inversion. So these are called logical operators. Then there is something called any. Any means true if any element of the vector is non-zero. Now let me see, okay, but you said that it will be operating in the binary. Let me see, I take x any arbitrary value. Let us say I will take x some rand 4, 1 vector. If I write or x, what do I get? Let us see. It will not work actually, because so I write not x, and I will write or x will not x, not x will what? So y is equal to similarly rand, let us say 4, 1. So if I write x then or y, how do I get? So that means any non-zero value will be taken as 1. Similarly x and y will be all 1 1. That means any non-zero value will be taken as 1. Let me take x is equal to positive, both positive and negative. Let us see what is happening. Rand and 4. So x is 4, 1. So x is this and y is this. Now you write x and y, what is happening? So again any any non-zero value will be taken as 1. So that is what, if you give x other than logical values, x should take 0 and 1. Even if you don't give 0 and 1, you give some other value, unless it is 0, it will be taken as 1. All right. So now any is what? If it will give a logical output, any of the element of the vector is non-zero. Similarly, it will give you true if all elements of the vector will be vectors are non-zero. Okay. So these are logical, they will give you logical outputs. How you can use them? You can use them for exception handling. If you are in the middle of a program, and if you want to see that a particular matrix or vector is becoming 0 or non-zero, you can do that. For example, suppose I write any random 4. So it is, what is random 4? Random 4 is what? It is a matrix 4 by 4 like this, random 4. It is a 4 by 4 matrix. So any x means it will take each column. It will take each column, then find out if in that particular column whether that matrix is having any of the elements are 0, but it did not find true if any of the element is non-zero. That means all the elements are non-zero here. So none of the element is there which is non-zero. Suppose I write x 1, 1 as 0. So if you write all, you will find all means what? You can see all means true if all elements of the vector is non-zero. But you will find in the first column there is one which is not 0. So you can see, imagine that each column is going as into that particular function all, and each column is checked as a vector. If any of the element is 0, then that particular output becomes 0, right? Otherwise it becomes 1. So that is all about logical operators. So these are required when you go for if and exceptional handlings. Okay, if then else and while and exceptional handlings. So this will be very important and interesting. Remember, equal, not equal, they can be used as a function, or you can use symbols. Similarly here you can, there are only and, or, not, XOR, any, all. So these are used again as functions, and some of them can be used as symbols, like you can see these symbols, double and, double, they are called short circuit logical OR. So this will not be discussed right now. So these are not very important, these two are not important, so these are all important. Now look at it, special character. What is the special characters? Colon, parenthesis, punctuation, then transpose, C transpose, complex conjugate transpose, horizontal concatenation, vertical concatenation, subscripted assignment, subscripted reference, subscripted index. What is this? So the corresponding symbols are all here. You can see this. Colon will have a symbol like this. Similarly, parenthesis will have a symbol like this. Square brackets will have symbols like this. Braces will have symbol like this. Similarly, function handle creation symbol like art. These are art. Then the dot, then double dot, triple dot, we will see each of them separately. Now let us go to the first one. The first one is so these two functions, short circuit logical and short circuit OR, is not here in this particular version of MATLAB. So go for colon. So what is this colon? The colon, as you can see, has got lot of implications. Let me do it here. Suppose I write 1 colon 8. What do you get? You get actually numbers from 1 to 8. That means using colons, I can really generate vectors. Let me write. So let me write clear CLC. Okay, now write A is equal to 1 colon 2 colon 30. What are you expecting? You are expecting this will be a vector starting with 1 with a spacing of 2, it will go up to 30. I will put transpose by this, that means you will get a column vector. You can see 1, then followed by 3, then 5, 7, 9. Suppose I will write A is equal to, suppose some B is equal to 1 colon 10, then 20 colon 30, then 50 colon 5 colon 100, and transpose. What do you get? You get first elements 10 elements 1 to 10. 1 colon 10 means 1 to 10. Then there will be nothing. Then next 11 elements 20 to 30 will be 20, 21, 22 up to 30. Then there will be nothing. Then there will be again jump to 50. So next elements will be 50, 55, 60, 65, like that. So you can see. If you want to see that, you can just plot a bar B. First 10 elements, it is going from 1 to 10, next is going to 20 to 30, then 5, 50 to 100. So this is how. That means this axis represents the values, this is the element number. Is that clear? So using columns, you can do a lot of things. Now again, another use of column. Suppose I have a matrix A, just you have A, some a big matrix, let us say. I will write A to be right rand matrix, no problem, 5 from 5 or 4. So this is the matrix, right? It is not coming here anyway. So this is the matrix, right? A. Now I want to extract a portion of this. Suppose I want to extract only this portion, this element, this element, this element, this element. So this starts from which row? It starts from second row, it goes up to third, fourth row. Then here it goes to column wise, it starts from second column, goes up to third column. So I can generate that. Suppose A, then 2 column, second column to second row, sorry, the first is row. So second column to, it goes up to fourth column. Then I will extract second column to third column. So second column to third column. So that means this will generate a matrix, let us say B, which will take values, a portion block of the matrix, that is this matrix, from here to here, this element, this element, this element, this element, this element, and this element. So this portion of the matrix will be taken. You can see this 0.5936, 0.6449, 0.496, all those things are here. So that means 2 colon 4. Now again, another thing, suppose I will write A just column. What do you expect? This particular matrix will become a vector, one column following the other column. So one column following the other column. You can see this. This becomes a vector. Beautiful. Suppose I write like this, column 1. What does it mean? Suppose I write x is equal to this. That means column means it will take all rows, but it will take the first column. That will become a vector. X becomes this. Similarly, I can write suppose 3, then column. What does it become? That means it will make the third row and all columns. So that will become a column vector. So this is beautiful. You can use column to your advantage. You can use column to vectorize a particular matrix. You can use column to find out a block of a particular matrix. You can use column to find out to make extract a column, a particular column or row. Suppose I can write a suppose I write like this, 1 2 then colon. What does it mean? Tell me. So this will become, it will take 1 2. I am putting square brackets. This here also you are knowing, I am putting a square bracket like this, then I am putting a chord bracket. So this square bracket is a matrix. What is 1 2? It will be a matrix. That means first element is 1, second element is 2, and this colon means it will take all the rows because it is in the second. So in the second index, so it will take rows. 1 2 means it will take first row and second row and generate a matrix taking a first and second row of A. You can see, got it. You can also generate, you can put the fourth row first, then followed by one first row. You can do that. So this is indeed beautiful. You can make use of this colon and square brackets very nicely. You can see here, if you have any doubt, you can see all these things are nicely written here if you have any doubt. So make use of columns. We will come across this again and again. So now let us go to the next, parenthesis. I have already told about the parenthesis. You have got different kinds of parenthesis. One parenthesis is chord, then you have got some braces, something like this, curly brackets you call it sometimes, then square brackets or brackets. So there are three different brackets. So you have already come across these brackets where you have used it to generate arrays and make arrays and vectors. You have also come across this where you have used for assignments. Okay, but you have not so far come across this. What is this? This is actually create cell arrays. Cell arrays means these are all mixed arrays. For example, A, suppose I can make, suppose one character, then followed by number, then followed by 4. So you will get A some number. So what is A1? A1 you will get H, but what is A2? A2 will get nothing, because you see you have, it is a mixed thing, but the moment I will make a curly bracket, I can have this mixed representation of numbers. You can see that means A, if I write curly bracket 1, you will get H. If I write curly bracket 2, you will get 3. If I write curly bracket 3, you will get 4. That means using these curly brackets, I can represent cell arrays where I can have mixed representation, where I will have mixed representation. But here actually I cannot have this mixed representation. You see, this became blank. It is not, you are not able to do it, right? So that means this is the curly bracket where you can have cell arrays, and this is the square brackets we have already done using the square brackets, right? And the or brackets also you know, right? Then punctuation. Punctuation, actually one such punctuation is dot. So this dot is you have already done. You can for element by element division, C is equal to A dot plus B. Then decimal point. So this you have already done, but you don't know what is a field. So the field actually is something, it is just like matrix. For example, you can use, but it is not a matrix. Suppose A you want to make a field, so you make clear everything, CLC. Suppose I can write A dot 1 is equal to ran 3, it's a random matrix. Now A dot, so it has to be variable X. I will generate a field. So suppose I have no variable now, nothing is there, so I want to generate a field. So how I will generate a field? So let us say I am to generate a field A. So A dot, you cannot give number, so A dot X, let us say, is a matrix. Okay. Then A dot Y will be some character. Okay. So A dot J will be some complex number, square root of 1 plus j into 8. So what is j? J is a square root of -1. Always remember, j is square root of -1. So 1 plus j8 in MATLAB is taken as a complex number directly without any difficulty. So you can see what is a. So A is becoming a structure. What is A dot X? It will give you the matrix. What is A dot? What is the next? That is A dot Y. A dot Y will give you the character, and A dot Z will give you the complex number. So that means using only A, you can save many things. That means a total structure can be saved in one field, one way with different fields. So we'll go move into the, we'll continue with this next class. Thank you.